Hello and welcome to Tribe Topper. In this video session, you are going to learn about some of the problems based on centripetal force and centripetal acceleration. So our first problem is that the coefficient of static friction between the tires of a car of mass 1100 kilograms and dry asphalt is 0.80. Determine the maximum speed with which a car can take a circular turn of radius 95 meters. Now, since in the topic of friction, we learned that the frictional force between the tires and the road provides the necessary centripetal force for the car to take a circular turn safely. That means we are going to equate the centripetal force with the frictional force. So this is what we have to do. Now, what is the expression for centripetal force? That is mv square by r, and that is going to be equal to the maximum frictional force, which is mu times r. Now, by Newton's third law, we know in a vertical situation, like if a car is going like this, then the weight acting downwards is exactly equal to the reaction upwards. So, R is equal to mg. So, I would say mv square by R is equal to mu times mg. So even if they would not have given us the mass, it won't matter because the mass and mass would cancel out. Therefore, what is the maximum speed that is allowed is v square is equal to mu times r times g. Therefore, v is equal to square root of mu r g. Now we just plug in the values that we have. Mu is 0.80 times the radius of the turn is 95 meters given to us times g, which is 10, and solving this we get 27, or actually 27.5 meters per second, but you can write it as 27 meters per second. Right? So this is the maximum velocity. And how do we get it? By simply knowing the fact that the centripetal force is provided by the frictional force. So just equate the two forces, and solving, we get the velocity. In the second part of the same question, they say in wet conditions, the coefficient of friction is reduced to half its value in dry conditions. So what will be the safe maximum speed now? Obviously it will be reduced because the coefficient of friction has reduced. So for a safe driving, your maximum permissible speed will also decrease. Now we know what is the formula for v. The v is equal to the velocity is root mu r g. They say that the mu is now reduced to half. So if v was this, the new velocity is equal to, just everything else is same, mu becomes half. So I can take this outside as 1 by root 2 times root mu rg, and we already have the value of this as 27. So 1 by root 2 times 27 gives me a velocity of 19 meters per second. Of course it is a reduced velocity. The next question says that a particle is tied to a string and moves with constant speed in a horizontal circle. The string is tied to the ceiling, and draw the forces that are acting on the particle. So we just have to label all the forces that will be acting on this particle moving in a horizontal circle with a constant speed. So here we have the forces that are acting. See, this is your particle which is tied with this string with the ceiling, say at point O, and it is tied and moving in a horizontal circle, rotating like that. So the two forces that are acting on it is, one is the weight acting downwards, mg, and the other is the pull in the string, that is the tension towards the point of suspension. But we can't leave it here because your tension is acting at an angle theta. So there will be two components of the tension, one as the horizontal component TH and one as the vertical component TV. And what will be the value of this vertical component in case you have to evaluate anything? The vertical component, because this is theta and then this side is alternate angle, so this will also be theta. So if I complete a triangle from here, then this forms the base. And then in that case, whichever side is the base and the hypotenuse, that side we have the cos component. So TV is going to be T cos theta, and TH is the perpendicular component. So TH will be T sine theta. So these are all the forces that are acting: weight downwards, tension T at an angle with the vertical, and tension will be split up into two components, the horizontal and the vertical components. And the last problem says the rotor is an amusement park ride that can be modeled as a vertical cylinder of inner radius rotating about its axis. When the cylinder rotates sufficiently fast, the floor drops out and the passengers, they stay motionless against the inner surface of the cylinder. So like you can see here, the person is standing, he's stuck to the wall of the cylinder, inner surface of the cylinder, and the floor has dropped down. So there is nothing below him, but he doesn't fall down. The diagram shows a person which is taking the rotor ride. The floor of the rotor has been lowered away from the person. So you have to draw and label all the free body diagram for this person. So now here is your person. What are the forces that are acting on him which keep him stable in that position, stuck to the wall? So the forces acting are: one is his weight, which is acting downwards always. Another, because he's pushing the wall, so he's receiving a reaction. This is the force on the person. And because he doesn't slide down, that means if he tends to slide, the force of friction is pulling him upwards along with the wall. So here is the force of friction. So center of gravity will be the point where the weight is acting, but here from the side is the force of friction. So these are the three forces that are acting on this person. So that's all for this video session. In the next video session, you are going to learn about the safe velocity for turning on a horizontal road. Thank you.